everyone, I'm Sharanya PS, Assistant Professor, Department of ISC HAIT Mangalore. In this video lecture, I will be dealing with C Programming Laboratories program to develop find the square root of a given number n and execute for all possible inputs with an appropriate messages. Here, one major condition is to should not use any library function to find the square root, that is sqrt of n should not be used in the program. As the question says here, the main objective of this program or this experiment is to implement a program to find the square root of a given number. Here n refers to the number that is taken as an input from the user, and how to entirely execute all the possible inputs. That is, it need to process with the given input and it has to find the square root of a given number. That is, what is the root of a given number? Find the square root. And then it need to display with the proper messages. And one major condition here is, as we know, here under math.h there are some header file, some functions which are defined under math.h header file. These are the functions that we normally call it as a mathematical functions which can be used directly in the program. Here the condition that is given in the problem statement is should not use the library function sqrt of n. This is the given question. If we look into the program, this is the 11th program in the CPL lab. Here develop a program to find the square root. If we begin with the code, we have started with the standard io.h header file and we have defined two variables n and sqrt, where n refers to the number that is taken from the user and sqrt refers to the final display of the result that it found the square root, and I is to process with each element, that is to process with the looping statements. That is what we use here is a for loop, and we are taking the input from the user, enter the number, and it is stored in the variable n now. And here, as we know, we have to first check in order to find the square root whether that number is greater than 0. If the number is less than 0, then there is no meaning in finding the square root of a given number. It could write some error message. So here the first condition is to check whether the number that is entered by the user is greater than 0. If this condition is satisfied, then this sqrt is a variable where it stores the final result. So here we are trying to find the half of the given number, that is n divided by 2 will fetch the value, that is half value what we are mentioning with respect to, that is for the given n number it will be calculated and it will be stored in the variable sqrt. Next, with the for loop, I is starting with 0, I is less than n, I plus plus, it will process one major condition or the equation that I could say here, that is sqrt equal to sqrt plus n divided by sqrt and which whole divided by 2. This is the formula it may use to find the square root of a given number. Now with the next analysis part, I will be dealing with this formula. What does it mean exactly? After that, with the printf statement, we are trying to print the square root of the given number. And otherwise, that is, these are all written within the if condition. If this condition is false, so in the else part, we have written one error statement, that is not possible to find the square root of a given number. That's why if this if condition is not satisfied, then else part will be executed. The main agenda here is it lies under this formula what we use, that is square root equal to square root plus n by square root whole divided by 2. That is, here we are already calculated the sqrt by referring n by 2 initially. After that we are reframing this sqrt by referring to this formula. Next we are terminating the code. That's all with respect to finding the square root of a given program. It is very simple program. Now if we look into the output here with the execution of gcc lab11.c, here this is a compilation, and then /a.out is for the execution. First it asks for the user to enter the number. Suppose if the user has entered 64, then the square root of 64 is 8. That will be displayed as a final result. If we look into the complete process of how it will be calculated, as we observed, this is a code what we have written, that is, if n is greater than 0, that is first if condition, otherwise it will move to the else part. First it finds the square root, that is n divided by 2, that is half of the given number is found, and within that half range we are trying to find the square root of that number. And for is starting with I0 and I less than n, and with this formula it is finding the final square root. Now coming to here with this example, n is given by the user as 64, and it checks the condition if 64 is greater than 0. If this condition is true, and then it divides sqrt, that is equal to n by 2, that is 64 divided by 2 will yield you the result as 32. That is referred for the next step, that is for loop I equal to 0, I is less than n, I plus plus, and it once again finds the square root and it will be stored in variable sqrt. And when I equal to 0, this is how it will be calculated. sqrt refers to the 32 number plus 64 divided by 32 and whole divided by 2. This yield the result as 17. This need to be repeated until less than n, that is until the n value is becoming 64. So this is how with each I value varying, it is computing the square root sqrt. This only one thing major here is to remember this particular statement, that is to find the square root of a number. Next with I equal to 2 and I equal to 3, and like this it will be keep processing and finding the final result of a given question. This is one kind of the analysis what I have discussed. You can take any kind of the analysis to resolve this program. So with this I equal to 3 and 3 is less than 64, even though this condition is true, this process will continue for the next. So finally here the final resultant is already computed as 8. Next, moving further, the one more program that need to be explained under C programming laboratory here is that is the last program, that is develop a program to compute the sign of x using Taylor series approximation, and compare your result with the built-in library functions and print both the results with an appropriate message. Here the main objective of this program is to compute the sign of x, that is sign of x value need to be computed, but by using the Taylor series. We'll see what is this Taylor series later and compare the result what it is obtained with respect to the built-in library functions and the program what we got as a output, and all the details need to be printed onto the screen as a final result. Now if we look into the implementation here, before implementation, few points with respect to this Taylor series. This is an expression of a function into an infinite sum of elements which increasing exponents of a variable like x, x square, x cube, like this. This is the one what we refer as a Taylor series, and the sign of x Taylor series will be like sin of x equal to x minus x cube divided by 3 factorial plus x to the power of 5 divided by 5 factorial. Like this it continues. One main observation that we could make it is there is a alternate minus and plus symbols, and here x refers to the number and its cube divided by 3 factorial. Like this, for each odd numbers this denominator is referred. For the here with the x cube, x5 and x7, it is referring the value raised to 3, 5 and 7 respectively. Now in the implementation of this series, we enter the x value in degree, and degree need to be converted into radians. If we look into the formula for that, when we after that, once again, if we need to convert x, that is when then calculate each term and add it to the existing sum to obtain the sign value. That is, after converting the given number into radians, that is entered by using the user, that is the value entered is in degree and it is converted to radians, and here it need to calculate each term and add it to the existing sum to obtain the sign value. And here, in order to write this program, we have to write the math.h header file, since sign of x built-in function we are using. This is what we refer as a Taylor series. This x refers to the number what we are referring here, and that is x cube divided by 3 factorial, x to the power of 5 factorial, minus x to the power of 7 divided by 7 factorial. Here one observation, first observation is there is alternate minus plus symbols, and first number that we are referring here is a x, and second number here is x cube divided by 3 factorial. But by referring to the previous number, we can write this x cube divided by 3 factorial as x to the power of 1 into x squared divided by 2 into 2 into 1 plus 1. That is, it all together, if we refer, it will be 3 factorial. This is how, that is x cube that we refer here divided by 3 factorial is mentioned. Next, coming to the third term, here it is x cube divided by 3 factorial and x squared divided by 2 into 2 into 2 into 2 plus 1. This is how we can refer to 5 factorial. And same way, the fourth term is x to the power of 5, as we observe here. This is the symbol minus. If it is there, it will, when we open the bracket, it will become the plus symbol. And here x to the power of 5 divided by 5 factorial, and x to the power of 5 can also be written as x square by mentioning, that is 2 into 3 into 2 into 3 plus 1. This is what we refer as a 5 factorial. In general, if we define the formula for this, is a minus of ith term into x square divided by 2 into I into 2 into I plus 1. This is the formula that we are referring in order to calculate the value. This is the generalized formula with the ith value. If we look into the code here, the main objective of this program is to find the value in here. First thing here is we are converting the given value in here, that is x refers to the value in degree, that will be converted into radians. This is here, this is example. Here I and float degree x comma sum comma term. Your main objective is to find the sign of x value and need to compare with the two different systems. And here it finds the x value by referring to formula degree into 3.14 divided by 180, and these values are stored in the other variable for the further references. And with the for loop it will find that is I equal to 1, I is less than 10, I plus plus, and with this formula it will calculate the new term, that is minus of term into x, and it need to be closed entirely within the brackets, that is 2 into I into 2 into I plus 1, and it computes the sum as we followed in the previous class sessions. And after completion of finding the sum for the given number, it will be printing the calculated the sum is, and also the mathematical sign in the value is will also be printed. These two values need to be matched so that it can be mentioned that your sum and sign of x need to be matched with the final result. Then we can mention that the program what we have implemented is correct. If you look into the output here, enter the value of in degree. 90 is entered as an input, and it will be calculate the sum, and mathematical sign value will also be displayed. And here if you refer to 9, the enter the degree value in 90, actually it will be converted, the final, that is the calculated sum will be 0.999 like this, and it will be truncated here. Either you can write like this, or you can use the actual value without using any truncation as well, since it was defined as a float. And while calculating this, that is while calling this program, we have to mention one major thing is here cc program name dot c, and minus lm is the mandatory statement, that is minus lm is a word that it is used along with the compilation with if it has the sign value, that is mathematical function. This is the to program that I wanted to discuss under the lab. Here main objective is to calculate the value in degree, and then it will be calculating the x value, that is degree into 3.14 593 divided by 180, and these values are stored in term and sum so that it can be referred by using these variables. This is how this program can be implemented. Parallelly, please go through with the corresponding algorithm and the flow chart. This is what we refer as a program to generate the sign of x, and the program to that is find the root of a given number. These are the two programs that are discussed here. These two values need to be same so that we can conclude that the program written is correct, that is calculated sum is and the mathematical sign value need to be the same. And if we show the execution of this, and if we observe the output here, and this is the same program that I discussed just now, need to convert the given number into value in degree to, that is whatever the number given, it will need to be converted to degree, and after that it need to find the x value, that is by degree into 3.14 divided by 180, and it finds the for loop. With that it will find the corresponding term value, and it will be just keep adding to the sum variable here. If we execute this, it will give the two results, that is enter the value in degree, and if I give some values in degree, it will be converted into sum, and that sum value will be displayed onto the screen. So here what it displays is it is seen for everyone, whereas the second case is very knowingly will know the values. This is how we can run the code which will have these many concepts. I hope it is clear. Thank you for listening.